Hello everyone. Okay, let me see if I can turn on the flash. Yes, I can. So I'm again starting to work on STM32 board. This board, which I found in my old toolbox, got the. Let me see if I can zoom in or see now. Basically, it has the STM32 F1 F407 chip. Okay, so I again opened the. I have bunch of boards which I bought but never used, like this STM32 Discovery. Yes, I slightly use this board. Um, then I have this Arduino Mega ADK. This is Arduino Mega, but this is have the ADK support. What is ADK support? Uh, ADK is basically to this. These are the USB host, and you can connect your Android phone with it. So that's how it works. I don't know this option. Your video is needed to start highlight. Okay, so let me figure out. Uh, STM32 F4 discovery board, and what feature it got. First of all, obviously it has the ST Link debugger, which is this one, and it has digital accelerometer. I will try to use this. And what else? One digital microphone. And again, I have on this discovery board. What else do I got? One audio DAC. So we have a DAC. In this board, and this port has one more unique feature, which is thank you Elizabeth and Z Kimmers. I'm just brushing up my STM32. So this discovery board, I'm trying to think of new projects which I can do for my YouTube channel. So I'm just thinking, bootstrapping. I'm just thinking what I can do for my upcoming videos. So I'm just refreshing what this discovery board built-in have, so I can so that I can have um, use that accessories. Okay, so I have accelerometer. We can definitely do some gesture recognition task with this accelerometers, which have we have built in on our STM32 discovery board. Instead of using a machine learning, we can try machine learning on STM32F4 discovery board, because the ST-Link created a tool which helps to build a neural network onto STM32 platforms. Although the STM32F4 is not capable of handling such strong machine learning and image processing, but what I um, what I do, you know um, I prefer to use not overkilling, not doing so much, you know um, I try to use simple methods, simple algorithms to do some task. If a task could be done with some simple algorithms, it should not be used with neural networks. I don't prefer to use neural networks for every simple task. So yeah. Okay, so for example, if we try to make a gesture recognition with the STM32F4 discovery board, we can use the DWT algorithm, sorry, DT, dynamic timing frame, DTW algorithm, which is not like simple comparison. For example, if we have an array like this, for example, we have a time series data of just like the accelerometer have the time series data. So for example, we have something like this, and we have another data of accelerometer which is pretty similar but starts from something different with different phase shift data. So instead of matching point to point, we will try to match for a better start like this. So it helps to do the gesture recognition with okay, I don't know about some commands to turn off. I'm just pretty new to the stream, I'm doing it for I think second time on this my channel. Okay, so going back, we have accelerometer. I think I guess the very good project which we can do is gesture recognition on STM32F4 discovery board with DTW algorithm. That could be a very good project. Then we have a digital microphone, a DAC, and a built-in integrated. The DAC is integrated with class D speaker driver, so we can attach a speaker for some kind of audio playing. This board have a built-in speaker driver, we can use that, and it has onboard LEDs. I just forgot, these are the LEDs, 1, 2, 3 and 4. The pretty much hello word for this board is with these LEDs. Okay, so we have 4 LEDs and 1 push button. Yes, we do have USB OTG, which is this is a ST-Link programming area. So this is ST-Link for programming this chip, but this is for USB hosting, and this is something external audio. Okay, we have a USB OTG micro AV connector, and well, I think this is enough to know about this board for now. For adding some kind of display, we have two options. We can either attach this LCD um, I2C with the I2C interfacing. I have never touched the I2C interface video for on my channel, so this is a very good option to use the I2C LCD with the STM32 for my upcoming video. So this one could be a good video option next. But instead of making interfacing videos, I am thinking to make some complete project. So to give some kind of display, we could use that, or we can use the OLED. Um, so we do have this 7-segment display as well to be used with this one, with the TM1637 chip, I think. Yeah, TM1637 chip. So it only require clock, DIO, VCC and ground. So this display option we do have. Let me check what else I do have. Yes, I have this OLED. So using OLED is also a good option. So we should add one video for this TM1637 display, one for this I2C 16:2 LCD, and one for OLED. So these interfacing upcoming video is a good idea. But for the gesture recognition, starting with a simple display, for example, if we do some gestures 1 2 3, we use this, but we have to make a training data as well. So what I'm thinking is, let's say I have this STM32 and I think there should be a FT232 chip for serial to USB conversion. So I send some data to the PC, and well, for example, we have accelerometer. Like if I add some external accelerometer on SCL SDA, this is I2C interface. I2C interface is a two-wire interface, so we just need two wires. SCL is called clock, and SDA is for data. So we have two-wire protocol. Although the the RS232 protocol is also a two-wire protocol, which requires a TX which is connected to other pins RX, and the RX of this device is connected to the TX of the other device. We need a TTL to USB converter, which converts this microcontroller's voltage level to convert on a USB protocol, which could be added to the PC. So that's how we could make this. And for example, let's assume we are using MPU 6050 accelerometer, and this accelerometer will give data to the STM32, and STM32 will pass this data via USB to the PC. So like if we are using this STM32 F4 discovery board, or if we want to make things a little bit simpler, the same code could be used. Let me check what I have in my. So this is a FT232 chip. Okay, I must have some open. Let me see what I have in my. So this is ESP32 cam. We can make some projects on this for some image processing task. Recently I uploaded a video on my channel with the ESP32 cam, where I use this ESP32 cam for a QR code scanner. So I built a video where I use this ESP32 cam for a QR code scanner. So how the QR code was working, let me check. The ESP32 cam itself is not capable of doing much image processing, although there is edge impulse which used the ESP32 for machine learning tasks. But in my opinion, it is not very much capable of doing things because of the limitation. I soon run out of the memory errors, So for example, let me how I make the QR code scanner. I send the data. First of all, I take image on the ESP32 cam. So I snap a picture, assuming that picture is of a QR code. I convert to base 64 encoding, and I send that base 64 encoding to the API, making post request. What the API do? API took that base 64 encoding, and I created a Next.js app for this API task. So the QR code converted to the base 64 encoding, sent to the API via post request, and the Next.js API received that base 64 encoded image with the help of post request and decode that base 64 encoding. And after it decode base 64 encoding, what it do is I not have a sound. After decoding the base 64 encoding, it decode the QR code, or whatever text back as a response. So, and the ESP32 cam read back that response So that's how I built this ESP32 cam and Next.js API based QR code decoding. So yes, I do work on Next.js. I do work on Django. Obviously, in Raspberry Pi, I learned the use of Python for the machine learning. Nowadays, I am working on Tiny ML. So, trying to implement machine learning on microcontrollers. Okay, so let me see what else do I got. Let me turn off the mic. So yes, the audio is working. I do apologize for the background continuous noise because I'm on the market where This is an electronics market where everywhere is working on electronic stuff, so the noise is so obvious. Okay, moving back for our gesture recognition task, and for the OLED display, this is the library STM32 SSD 1306 library, which should be used with for driving the OLED or OLED. This is the driver. Here you can see these are the bunch of files which you need to copy in your STM32 discovery project, and SSD 1306, 1306H. These are all the configuration files which we need to put in our project, and we need to change this template, and we need to change this STM32 version, because we are using the variant of STM32F4. So we need to comment out the F0 and uncomment the F4, and we need to rename this file from as a conf template, and we need to remove this underscore template, and we need to save this SSD 1306 underscore conf.h. So we just need to save it like that, right? Okay, so after that we need to change if we need the fonts, we can utilize these, and we if our OLED is using some different height and width, we need to mention that here. So once we done, we are ready to use this in our its project. So for example, if we go to the example directory, we have a custom fonts as well. I think they gave some Python file to generate the font. So for example, these are the characters, this all of the text for which we need custom font. We have python generate.py file, so this file will generate the font, I think. I'm not pretty sure about that, because I just using this for the first time. Okay, so we have to go to the firmware. Here we have I2C, and if we are using the I2C, I think I forgot to mention that there are two kind of OLEDs, SPI and I2C. So yeah, if we have to use the SPI, we can use this example, SPI example, and if we have the I2C, just like I have the I2C right now, OLED, I will export the, let me just tell you how to figure this out. These are the pins. I'm not sure if they are visible. So for example, you can see, and these are the VCC, ground, SCL, SDA. First pin is ground, and the second is VCC. So for example, if I have this. So this one is labeled as ground, and the next one is written as VCC, which is for positive supply, and the next one is SCL, and the very next one is SDA, and we can pretty much leave the reset and other two pins. So we just need these pins, right? Coming back. Okay, in the main.c file we can add the header files. This is the main header file which we need to include. We can omit this test file if we are not displaying any test. And this one is I2C handle. If we want SPI, we can use that. And here we have the functions to initialize the GPIOs, to initialize the SPI, to initialize the I2C. And coming down, we are simply initializing the GPIO pins for SPI and I2C. The reset pins. Okay, so let me start my cube IDE. Inside this cube IDE, we'll see how to configure our I2C pins for driving the LED. It's taking so long. I think it is being downloading some stuff. It should not. I'm opening this IDE after a long time. I haven't worked with the STM32 for a long while because most of the time the working is just on different microcontrollers. Okay, so I think I already have some project here. Okay, so let's just close the project. It's already just close this project. Now let's try to make a new one. Now we need to select our target, and because I'm using the STM32 discovery board, I can search. Okay, it is saying to search here. everything is very much messed. Okay, we need to go to the board selector. We try. Yes, I know the nucleo board, but I have this discovery and I prefer it over the nucleo. The reason, I don't know, just because I get used to it. Even the nucleo was not developed. Where are you? Let me have a search option here. We should have. What do we get there? There's something very, very much wrong. I know what the mass. I think my. Okay, so we got that. If you don't know, the green one is already being used and the yellow one is somehow being used, and this is the microcontroller name STM32F407 VGT, which we got in our discovery board, and the LEDs are being connected on port D of the STM32F4 discovery board, and PD12, PD13, PD14 and PD15. The blue LED is LED6, LD named with LD6, and is connected on port D15, and the red LED is LD5 named on the board and is connected on PD14 and up to so on PD13 and PD12 are orange and green. So these are the LEDs, and I2S for MCK, and these are the OTG pins. And coming here we have SW clock pin, I2S3 interface. Then we have the OTG and audio reset pin, the SWT pin, audio SCL pin. The point is you cannot use these pins, and you can only allowed to use the gray pins. So if you have to add some um, output, make some pin output, like for example you want to use the port C1, so you have these options here, the ADC1, ADC2, you can use these pins for that, either ADC1, 2 or 3 for the input channel of 11, or you can use the Ethernet mode, ETH MDC. I have to look it up what this actually means. Then we have GPIO input, GPIO output, GPIO analog, and the external interrupt. So these are the bunch of the options you could use. Coming here, we have the connectivity tab. There we need to select the I2C module. So I2C2 is not available because the PB10 is mapped with the I2S2 CK pin. So the pins are already mapped for some other thing. So we have available the I2C1, and I2C3 is somehow have this warning sign, so we also don't use this. So we make here, we will say we want to use this I2C, or otherwise if you want the SM bus blood mode or two-wire interface, you could use that, but we want the I2C module, so we are just enabling it. We have a bunch of configurations which we can make for the I2C, like we can change the clock speed, because if we want an animation to run on our OLED, we can increase this clock speed, so the faster transfer rate, so which means a faster refresh rate, and yes, bunch of that. Then we have some constants. If we want to add, we can even add some interrupt. So if something happens on I2C pin, we can enable the interrupt. And we have some GPIO settings like PB6 and PB9. So these are the pins which are being used. PB6 and PB9. So let's look it up. Where do we have that? But these are used with it should not be. Okay, let me look for some new green pins. What? Where are the pins? It says the audio SCL. So holding control plus mouse left button down to show the alternate pins, we can use that. So we can map this one. It will open up this window again, PB8 and PB9, but it is still marking it as user label. Okay, so these are just the labels, we can change that, it doesn't matter. Okay, cool. PB8 and PB9. Let me see, where do I get these pins on my board? These are the pins. So these are close to the VDD, PB9 and PB8. So these two pins, we have the VDD pin closer to it, we can use that. So the PB9 is SDA. So if we just make it PB9 is SDA, and obviously PB8 would be the SCL. Okay, so I have to end the stream for here because I just created this stream for testing. Thank you to everyone who liked the video, and thank you. We have if you want the electronics videos, you can subscribe to my channel and like the videos. I work on embedded systems and lower level programming, also a little bit of web dev for the IoT related tasks, so like the Next.js, Django, Python for machine learning, depending on the project requirement. If you want to discuss some project of yours, you can ask